We're in Module 6 looking at the novice problem number 5, and this is part 2. So let's return to that particular problem and see how we solved it before. Here's the problem that we had. It's an income statement, and we're trying to create a Monte Carlo simulation that gives us the risk profile, which is the variety of possible outcomes that are distributed from the assumptions made about uncertainty. So we built the model. If you recall, the model had three uncertain elements in it: units in sales, cost of goods sold percentage, and variable cost percentage, and we incorporated that into our model. And what we were interested in, the metric of interest, is this particular value here, which is our net income. And you can see that because I have placed that PSI output function there, this is recording through the course of the simulation all the different values that occur for this. And this is our risk profile here. How do we do that? Well, we could write PSI output in there, knowing that that's what needs to happen. But I can also go to results, output, and having put my cursor in that cell prior to doing this, it would identify it as an output cell. So for example, what if I wanted to track the earnings before taxes also? I put my cursor in earnings before taxes. It's there in N19. I go to results. I go to output. I put it in the cell. And then what you should see soon afterwards is that calculation that's done, N15 minus N17, plus that PSI output. So now it records output that results from the simulation. And if I hit return, or if I double click that cell, here is the EBT of our simulation. So you may want to see earnings before taxes also in the course of doing your analysis. All right. So I'm now going to go to the other questions that were involved here. The first thing we want to do is we want to collect data on this, and we want to simulate it. We simulated it 5,000 times, and I want to collect some summary statistics about that data. The summary statistics were given to us in those graphs also, but I can also do that by inputting a PSI function here. This is equal to PSI mean. I have to identify what it is that I want the mean of. So I place my cursor here. I go to results, statistics, mean. It asks me, please select a cell where the statistic will be placed here. And there's the mean of our distribution that's gone in that cell. You can see that it's PSI mean, and I have to identify in the quotes, in the parentheses, the value that I want. So I could write that out, PSI. Now I want standard deviation. All of the functions appear when you start to write. So where's standard deviation? Standard dev, right here. Double click that. It says what is it you want the standard deviation of? I want it of N23. Hit return. And there's our value. And I could do that for the median also. So how do I get the risk profile? Well, we know how to get the risk profile. We double click that output function. And here is our risk profile. And I can copy that. I can put that onto a clipboard. Another thing we can do, and we will do, is we're going to ask some questions about what the probability of a particular output is, and we're going to ask the probability of this outcome being 0. In other words, what's the probability of losing money or not making money versus, and D, the probability of making more than $70,000. So the way we do that is, here's our distribution, our risk profile, and I simply click on this value here. This the standard approach here is to say, all right, where's the 5th percentile? Where is the 90th percentile? Approximately 90% of the outcomes are here, and what's the 5th percentile here also? Not quite that, because of, you know, the nature of fractional values. If I click on this value 28 and I set that to 0, hit return, I'm now told that my probability of 0 or less outcomes, in other words, negative values up to making no money, is 14.72%. So that's my answer here. And then I'm asked the question, what is the probability of getting 70% or more? So let me set this back down to this area. You know, you can move these guys around by manually and try to get that value. Here's 70%. Let's say, yeah. See, it's hard to manipulate this. It's much easier to just, here I've got 66.9% up to this point. So let me just right click this guy and type in 70, not 70,000, but 70. We are looking for 70,000, but these are in thousands. And then the probability of 70,000 or more is equal to this area of the curve, which is about 13.62. Note that this will be different for every simulation. Every time you do a simulation, you'll get slightly different values. But if the n of the simulation, the number of iterations, the number of experiments, the number of observations that are recorded, is large, then it should be fairly stable. So there we have it. We've been able to get output. We've found important information relating to these probabilities of potential outcomes, and the information that is available from these graphs is really, truly phenomenal sometimes. So I've pasted my distribution there, and I think the problem is complete. Yes, it is. All right, that concludes problem number 5, part 2, module 6 in the novice problems.